Hi, this is going to be a lecture that describes some of the caching behavior that's present in the Chrome web browser. This is an important skill to understand in order to do web application development effectively. My name is Professor J Patterson. Browsers generally cache information in order to make repeated network requests faster. When you develop web pages, it's important to understand whether caching is on or off, and caching can be pretty confusing during the development process, so you probably want to turn it off. Here's the problem that caching solves. Sometimes the network is slow. We may request an image from a web server, and that image might be quite large, and so it takes time for that image to be returned to us. It might be the amount of time that's noticeable to a user of a web page. So the solution to a problem like this, one of the solutions to a problem like this, is to recognize is that if you have recently asked for that picture from a remote resource, rather than asking for it again, why not use the copy of that resource that you loaded last time? Just save a local copy so that you don't have to go out to the internet and get that copy again. So if you have recently requested an IRI or an internationalized URL, you can just use the last copy you received instead of asking for it again. This is something that the browser does automatically. It uses the cache. So here's an example of that. Here is a web page that we're going to load up. It is a web page that I made just to demonstrate caching behavior. And it contains a little bit of text and a really large image. If we inspect the contents of this web page and make sure that disabled cache is checked so that we get all of the resources fresh from the remote server, and we refresh the page on the network tab, we can see that 3 different resources were loaded here. Rendering this page took about 2 seconds. We rendered 3 different URLs and we transferred 18.3 megabytes of information. Let's take a look at how all those pieces, where all that came from. So specifically, rendering this page took 1.81 seconds. Where do I see that? Well, down here at the bottom. This is how much time it took to get all of the contents back to us. There are 3 different requests that were made. And the 3 different requests were made for these 3 different resources. You can see that this web page requires the original index HTML, and it also requires the image that is part of that web page. The 3rd request is for an icon file that goes in the browser toolbar up at the very top where it says MHCID sample page. That little image to the left is the icon associated with it. So this whole page takes 3 resources. We made 3 requests for those resources. It appears that all of those requests were successful, and so only 3 requests were made for 3 resources, instead of, for example, having to request a resource a second time. And then finally, we can see that 18.3 megabytes were transferred and that 18.3 megabytes of resources are present. Those numbers can be different because of caching or because of compression. In this case, there's no difference. There was no cache used and there was no compression involved at all. We asked for 3 resources, we got 3 resources, it took 1.81 seconds. No cache involved. We just loaded this web page, so let's see what the behavior is if we reload this web page using the resources that are cached in our browser. So now we're going to do the same thing with caching. And what we can see in this case is that we're going to uncheck the disable cache button so the cache is enabled. We reload it and we see that it is much faster in this case. In particular, it only took 0.118 seconds to load. Remember, the previous one without the cache took almost 2 seconds. So, a remarkable amount faster, almost instantaneous. It still required us to get 3 different requests, but these 3 requests were all cached locally, so they were returned very quickly. And when we look at how many resources were transferred and how many were required, we see that the same number of resources were required. At the end of the day, we had to have 18.3 megabytes of data in order to render this web page. It happened to be that they were all cached, though. And so we only requested 620 bytes of data, which is 0.0000006 megabytes. Like orders of magnitude less data was requested. Why? Because all of this data was present in our cache and a network request was not required. The overall user experience here is that after we made that first request, the second request was blazingly fast. Let's look at another example. This is a commercial website, CNN, a particular moment when I was recording this. And we can see that without caching, notice that the blue checkmark button at the top is checked, so the cache was not used. It took 17.85 seconds to render this web page, to get the contents of this web page. That required requesting 119 other resources from the internet. And if we look at how many resources were transferred and how many resources were required down at the bottom, we see that 2.7 megabytes of data was transferred and that 9.1 megabytes of resources were used. Now wait a second, the cache wasn't used here. So why isn't the same amount of data was 9.1 megabytes were required to show the page? Why didn't we need to transfer that many? Well, that's because many of the resources were compressed. So if the web page asks for resources in a compressed format, you may be able to transfer smaller file sizes than the space that they take up when they finally get to your browser. So in this case, in order to get the 9.1 megabytes of resources, we had to request files whose total size was 2.7 megabytes. When the browser received them, it decompressed that and expanded the size of the files and then was able to render the web page. Overall, it took 17 seconds. This was without any caching behavior. When we do it with caching, we get a curious result. For starters, it indicates that it actually took longer to render this web page, 32 seconds. That isn't what we expect, and I'll describe what happened there in a moment. But what did happen that we did expect is that the same number of resources were requested, but because we are using the cache and all of the resources were already in our cache because we just loaded the page a moment ago, we can see that only 181 kilobytes were transferred, or 0.181 megabytes were transferred. So we were able to use a lot of contents of our cache. We were able to use just a small amount of additional resources to get the total 9.1 megabytes of resources that are required to render this page. Why did it take 32 seconds to render this web page instead of the smaller amount of time before? Well, that's complex for a website like the CNN website because the CNN website is never done reloading. It is always going out and requesting another resource to check to see if the news has changed, to make sure that the website is updating advertisements, for collecting statistics about the usage of the web page. That additional request happens, I think, about every 5 seconds or so. And it's a small amount of data, but what it means is that the website is never complete. It always keeps loading more and more data. And so 32 seconds is just the point at which I cut it off. I stopped recording the information that's coming in. Nevertheless, even though the amount of time that I was recording this web page went up, the overall amount of resources that it transferred was so much smaller because the cache was used. This is a great benefit for individuals that are using the web browser as a user because it makes your website appear as if it's loading much, much faster. And even though the news might change frequently, other components of this website, like the logo, a lot of the images that don't change very frequently, maybe even some of the underlying JavaScript, remains the same. And so in any given moment, you may be just requesting the same information. And if that's in your cache, then you get it almost instantly. Now here's a pro tip, and this is something that's going to be very important if you end up developing web pages. The cache can become very confusing for web application developers because you're working on trying to create a website. And as you change the contents of your website located on your server, your browser may not show those changes because it's using a cached copy instead. this can be very confusing. So you should know about the option of right-clicking the refresh button. When the Inspect tab is open, and only when the Inspect tab is open, you can right-click on the refresh button and have these 3 additional options provided to you. You can select a normal reload, which is when you just reload the web page using whatever cache settings you have set up, or you can force the cache to be emptied out and do a fresh reload as if someone who had never gone to your web page before was loading up the web page. This last option, to empty the cache and hard reload, is important to know when you're developing web pages because that's often the option that you're going to want to use as you're debugging the connection to your web server. So the impact of caching. Browser caching can greatly speed up web page rendering by eliminating redundant network calls. The downside is that if the remote content has changed and the browser is reloaded, the old content might actually be shown. This is mostly just a problem when you're doing development. And it's very confusing for beginning web developers to understand what's happening. And that's why I bring this option of the empty cache and reload and the caching behavior to your attention. So the key points. The browser caches information and resources to make repeated network requests faster. When you develop web pages, caching might show outdated information, so turn it off by checking that blue button so that the cache is disabled. Or make sure that you do a hard refresh when you load your web page in order to try and debug problems that you encounter. As you begin to develop web pages, I hope understanding this detail, this nuance of how browsers work, will help make that debugging process a little bit less painful. Thank you for your attention.